SwayamPrabha. Digital India. Educated India.
Good morning. Today we are here in Flight Laboratory, and I am fortunate to be surrounded by students of MIT, Chennai, and you all know Dr. Kalam was a student of MIT, and they are here as a part of their course on Introduction to Airplane Experiments in Flight. Today we want to demonstrate you how we can take the measurement of weight of an airplane. You could see before I go for Weighment experiment, let's briefly see what is an aircraft. You could see this is a fuselage, this is a flap, this is aileron, similarly there are ailerons and rudder. Now the question is why weight is important. After all, aircraft has to fly in air, there should be some force which should balance the weight, and how much upward force is required will be decided by how much weight of the airplane is. So basically the performance of the airplane is decided primarily by the weight of the airplane. For example, what will be the range or what will be the endurance, how much rate of climb, how much takeoff distance, landing distance are primarily governed by the weight of the airplane. Hence, it is extremely important to know correctly what is the weight of the airplane. When I say weight of the airplane, it means the airframe weight, the structure weight, fuel weight, along with the passenger weight, right? So now today, as soon as we realize that weight is so important, we should not forget from the stability and control point of view, center of gravity of the airplane in configuration is equally important. So we will use this experiment, we will try to understand the procedure to know how to find out weight as well as center of gravity of an airplane. For any measurement, you need a balance. We have a balance there. You could see that side, there are 3 balances. We will be soon focusing there. Before you focus there, we will request our student to drag this airplane to the balance. Let's drag this airplane all together. Okay? Thank you. Now you see that these are the balances, one balance here, another that side, another in the nose landing gear. Now we have to somehow measure the reactions happening at these 3 balances. So how do I measure the weight or measure the reaction at these 3 points? Since we need to measure it by a scale, we need to know what is the least count of these scales. What is the least count of this scale? It's 200 grams, right? So now you will see how to measure the weight. We will demonstrate it. Can you demonstrate how to take the weight? Slightly you have to take it back. Yeah, it's okay. Thank you. Mind your head. Huh? What she has done, you could see this is a scale here, right? And you have to make this scale horizontal. So first is you adjust from this lever, and for the final correction you do from the small weight here. Once this is done, it's like a vernier caliper. You read the scale, main scale and the vernier scale, and you note down what is the weight. Can you note down how much is the weight here? And somebody should write here at the back, 220? 243 what? 443, no decimal. Because 3, how it will be 3? 200 is the least count, no? 443.4 kilograms, okay. 443.4 kilograms. 443.4. No, 443.4. 4 only, 40. Okay. What about the nose? Somebody measure the nose. Come on. What is the problem? Can't you measure? We'll help you out. Come, first disturb the balance. See that this scale is down. We have to somehow make it parallel. So he will try to use the vernier. Do it. Yeah, it's balanced. Can you read the scale now?
650 main scale, sir. 4 and in points,
684.2. So the nose wheel reaction is 684.2 kg. What about the left or right landing gear?
No, 400. 400 is your main scale?
Where is it? Okay.
You could see that 400 is the main scale here, right? And vernier is how much?
40 plus 40.
2.
40.6.
Okay, 40.6.
That means it is
440.60.
Yes.
440.6. Okay? So this landing gear is measuring a reaction of 440.6 kg, right? Okay? What is your name?
Sangeeta.
So Sangeeta will help us now how to get the total reaction. Let me repeat. The left landing gear was weighing 443.4 kg and the nose landing gear here was showing a measurement of 684.20 kg and the right landing gear was showing 440.60 kg. So what will be the total? Is it okay? Everybody says yes. So what is the weight of the airplane? 1568.2 kg for this fuel configuration. This aircraft is not fully loaded with the fuel, so you can further add fuel. But the point is, the moment you want to fly this airplane, the passenger will sit here, so their weight has to be added when you are doing the experimental analysis, right? Now tell me one thing. Now see, we now know that weight is equal to 1568.2 kg. Now we want to know under this configuration where is the CG location. How should you find out? How to find it out? Anyone who can come? Boys or girls? Anybody? Yes, come. That's like Kalam, yes. See, we want to now find out what is the CG location, right? Center of gravity location. What data we have got? We have got one location here, one location here, another location here. And we know these distances. Let's say this distance is A, this distance is B, and this distance is C. These are known because landing gear is fixed. There is a geometric location. You can check the manual. You will find these lengths are given. Let's say they are A, B, and C, and this is the nose landing gear, right? So what is the reaction here we are finding? It is around 684.20 kg. And here how much? Left is 443.4 kg, and here how much? 440.60 kg. One thing you can clearly see that this left and right landing gear, they are almost measuring equal weight. That shows what? That shows there will be hardly any lateral shift in the CG. If suppose this weight was much more than this weight, that means CG would not be in the center line. CG would be, suppose this weight is much more than this weight, that means CG will be little towards this weight. But we want as a designer, the CG should be on the central axis. So this number when you see within this 3 kg difference, there may be so many other small accessories here. So you know one thing, that the aircraft is beautifully designed and CG will be in the center line. This is one observation. Now if I want to find out where is the CG of this configuration, it is very simple. You know how to find CG. Suppose this is the reference axis and there are three M1, M2 and M3. And you know their location A1, A2 and A3. How to find CG? Along x-axis, let's say. That will be what? XCG will be what? Will be M1, A1 plus M2, A2 plus M3, A3 divided by summation of M. The CG is that point about which net moment because of all mass distribution should vanish. Here we have got three forces, this one and this one. You take any reference, you take reference line, you can as well take a reference line from, let's say I am taking a reference line here. That depends upon you. You can take a reference line here also, then this product will be 0. So from here you know what is this distance, what is this distance and what is this distance. Let's say A1, let's say it is A2, let's say it is A3, and you know these forces. You find M1 into A1 plus M2 into A2 plus M3 into A3 divided by summation of M. That will give you a CG location. And you have already seen lateral shift is not there, so you can fairly assume that it is on the central line. Is this concept clear? You know how to find CG and how to find the center of gravity, right? Okay, thank you.
Okay, this aircraft is Piper Saratoga. This is the cockpit where I am sitting. This is the instrument panel you can see. These are the control sticks. Every aircraft has got dual control sticks. This stick you can compare it with your with the handle of your car or your cycle. If you do it like this, the aircraft bangs to left. If you do it like this, aircraft bangs to right. If you pull the stick, the aircraft nose goes up. If you push the stick, the aircraft nose goes down. Here you have a few instruments. You can see this is the altimeter, which indicates the altitude at which you are flying. This is your airspeed indicator, which indicates the indicated airspeed. This is your vertical speed indicator, which gives you the rate of ascent and descent of the aircraft. Here you can see there are 3 gauges in one. This is the engine instrument. You can see the oil temperature, cylinder temperature and oil pressure. Oil pressure is the most critical parameter which is to be observed when you start an engine. The very first thing which you have to observe is the oil pressure should register within 30 seconds of your starting the engine. In case if your oil pressure doesn't register, then you have to switch off and look for the reason. This is your fuel quantity gauge. This gauge on the left is for the left tank and this gauge on the right is for the right tank. This airplane has got fuel tanks in the wings, one in the left wing, one in the right wing. The total capacity of this aircraft, fuel capacity is 107 US gallons, out of which 102 US gallons are usable and 5 US gallons are unusable. This gauge you can see, there are 2 gauges in one. One is the manifold pressure gauge on the top and on the bottom is the fuel flow gauge. The manifold pressure gauge, this indicates the power being generated by the engine. This particular gauge, this is your RPM gauge, we also call it a tachometer. This indicates the revolutions per minute of the propeller. This particular plane, the maximum RPM is 2700. This gauge, this is your exhaust gas temperature gauge. This indicates the temperature of the exhaust gases. This is your artificial horizon, or you can say flight command indicator. This indicates the attitude of the aircraft, whether your aircraft is flying in a straight and level mode or it is flying on a bank angle. You can find it out from this particular gauge. Then these are your navigational instruments. This is your turn coordinator. Or you can see there is a bank indicator also there. You can see a black ball in the center. In case if the aircraft is flying in the straight and level mode, the ball will be centered, and if it is flying at a bank angle, you can see the ball will go either to left or right. Then you have this particular panel. This is your radio panel, where you have the radio sets through which you are in contact with the control tower and other aircrafts. This particular airplane also has an autopilot. Then this is your switch panel. You have switches for different circuits. This is your battery master switch. Then this panel on the right side is your circuit breaker panel. These are the circuit breakers for different circuits. Here on the instrument panel you can see these few lights. This is the annunciator panel. You have lights for different circuits. These are the warning lights. In case if there is any malfunction in any circuit during the flight, this light will glow. This will indicate that you have a problem in this system, and the pilot can take a call whether to make an emergency landing or to continue with the flight. This is the landing gear selection lever. These are the 3 green lights for the landing gears. This is for the left main landing gear, this is for the right main landing gear, and this is for the nose landing gear. 3 green lights glowing indicates that your landing gear is in the down and locked position. After taking off, once the pilot selects this lever up, then these 3 lights will go out. That indicates now your landing gear is not in the down and locked position. Once these lights go out, you can see here a red light, gear warning light. This light will glow. This indicates that now your landing gear is neither down and locked nor up and locked and is in the transit mode. Once the landing gear is up and locked, this red light will also go out. Similarly, before landing, the pilot will put the selection lever down. Again the red light will come on. This gear warning red light will glow. This indicates now again your landing gear is neither up and locked nor down and locked and is in the transit mode. Once the landing gears are down and locked, this red light will go out and these 3 green lights will glow. Then you can safely land. There may be a possibility in flight that you have selected the landing gear lever down, but your lights have not come on. Now you are not sure whether your landing gear is down and locked or not, and you need to land. In that case, in these kind of situations, you have you can see this red knob. This is the emergency lever. In this is the emergency lever. If you pull this lever, the landing gears will make a free fall and will get down and locked. How this is done? In the landing gear circuit, which is a hydraulic circuit, there is a shuttle valve which keeps the hydraulic pressure trapped. Once you pull this lever, that shuttle valve moves to one side, the hydraulic pressure is released, the landing gears make a free fall and gets down and locked mechanically. Then here you can see this is your fuel tank selection. As I have earlier told that there are 2 fuel tanks in this aircraft, one in the left wing and one in the right wing. This is the selection for the fuel tanks. This selection is for the right tank. That means the fuel supply will come from the right tank, and if I do it like this, on the left, the fuel supply will go from the left tank. And there is an off position also. If I have to shut off the complete fuel, now it is in the off mode. So you have 3 selections of left and right in this particular plane. You can see here, this is your parking brake. You can see here this instrument, this is the direct reading magnetic compass. Then this is your outside air temperature gauge, which gives you the temperature of the outside air.